So there are two types of averages that we are going to concern ourselves with. One is arithmetic mean and the other is geometric mean. Even within these two, the weightage of arithmetic mean is too much as compared to geometric mean. In all honesty, geometric mean is generally only asked in the context of AMGM inequality. That is generally the only use of geometric mean. A thing that we have already seen that CAT generally avoids giving you product sort of situations. Even in interest, we have seen that the default case is simple interest, which is addition, as against to compound interest, which is multiplication. So arithmetic mean is defined as the sum of the numbers in the data set divided by the number of numbers that you took to find that particular average. So if I have to define it, it will look something like this: a1 plus a2 till an. So I am adding n numbers, so I will divide by n. What this gives me, this arithmetic mean, this is a number which I can replace every value in the data set with and still get the same total as it was when all of these were their individual values. So this particular point, that all values can be replaced with arithmetic mean without causing any change in the overall sum, it is very important. This is something which we will see how it gets applied to solve certain type of questions. What this also means is that arithmetic mean will always lie at the center. So when I'm saying center, I don't mean the literal center between the largest and the lowest value. It may or may not happen. It will happen for something which is in AP. Otherwise, it is the weighted average. For you, what that means is that arithmetic mean will lie somewhere between the highest value and the lowest value. So arithmetic mean will be lower than the maximum value in the data set and greater than the minimum value in the data set. For you to have any sort of equality here, uh, you will essentially have to converge this data set into one repeating element only, in which case the arithmetic mean will be same as the minimum value, which will in turn be same as the maximum value. When everything in the data set is the same thing, only then will the arithmetic mean be equal to the minimum or the maximum itself. So arithmetic mean lies at the weighted center, and what I mean by the weighted center is that the sum of differences of the arithmetic mean and the values lower than it will be equal to the sum of differences of the higher values with the arithmetic mean. So for example, if you take the arithmetic mean of 3 and 7, you will get 3 plus 7 by 2, which is 5. And as you can see, the gap between these two is 2, and the gap between these two elements is 2. Because I only took two data sets here, the arithmetic mean actually lies at the literal center of these things. However, let's say I take three numbers. I take 3, 4, and let us take something which will give us an integer arithmetic mean. This is 7. So if I add 11, right? Let's say that the third number that I take is 11. So if I calculate the arithmetic mean now, I will get what? 11 plus 3 plus 4, which is 18 by 3, that is 6. Now, the negative differences are 6 minus 3, that is 3, plus 6 minus 4, that is 2. The positive differences are 11 minus 6, which is 5. And yes, 3 plus 2 is equal to 5. So again, this is a property which we will shortly see how to use. This exact property is something which you all know as allegations within the mixtures part. This is what mixtures essentially is all about. Now, a very specific type of question that we do come across in averages is an addition of new data point, either addition or subtraction of a new data point. So, if the new value that you add to the data point, to the data set is greater than the original arithmetic mean, that new value will essentially pull the arithmetic mean closer to itself, making the new arithmetic mean greater than the older one. If you add multiple values, if you add multiple new data points to the data set, and the average of these new data sets is greater than the original average, then again same thing will happen. This new addition of data will pull the arithmetic mean towards itself. So it will look something like this, that right now we took average of these three numbers and we got 5 as the we got 6 as the average for these three numbers. Now if I go on and add let's say 2 to this data point. Now 2 to this data set. If I go on and add 2 to this data set, 2 is less than 6. 2 is a value which is lower than 6. What this 2 will do is pull this arithmetic mean towards itself and decrease the arithmetic mean. The new arithmetic mean here is going to be what? 3 plus 4 plus 11 plus 2, which is 20, by 4, which is 5. So this value of 2 decreased the average from 6 to 5. If instead I had added something like, let's say, uh, 10. Now 10 is greater than 6. What this 10 would have done is pull the average closer to itself. And let's calculate. This sum is 18 plus 10, 28 divided by 4 is going to be 7. So your average got increased, from 6 to 7, because the new data point that you added was greater than the average. So this sort of situation where you had an average, then you added something to the data set, and then there is some new average, this is a very specific type of question that we will have to deal with, and the dealing will essentially be in two possible methods, which we will now shortly see. Finally, there is something called as weighted average, which again, if you remember, as I have told you, it is the mothership. Arithmetic mean is technically a specific case of weighted average. Weighted average essentially means that to each data point, I can attach a certain importance. For example, if a certain value occurs multiple time, it occurs multiple times in your data set, then that particular value becomes more important than the others. For example, if there are 50 people in one class and there are only 10 people in another class, you would ideally want the actual average to reflect this, that I have taken 50 students from the first class and 10 people from the second class. And the way to do that is, if let's say the average scores are A1 and A2 here, you will not go and do A1 plus A2 by 2 and say this is the average score. This would just be the arithmetic mean. It does not factor in the element that A1 is a score which is being scored by 50 students on an average, as compared to only 10. What I will instead do is I will do 50, which is the importance of A1, into A1 plus 10 into A2 divided by 50 plus 10. So this is the expression of weighted average. Weights into the value, summation of that, sum product of weights into average divided by sum of the weights. If you put all of these weights to be equal to each other, you will again land back at arithmetic mean. So arithmetic mean is nothing but weighted average, where you say that each data point is as important as the other one. All right, so far are we clear? So there are going to be four types of problem areas here. Standard equation and weighted average. This is going to be one of those situations where you have a word problem and the only way to solve is to actually write the equations for the average. Now, again, I am exclusively talking about arithmetic mean right now. So when you do write your equations for arithmetic mean, the thing that you have to focus, regardless of what the question is asking you for, is actually one of the things in most scenarios would be what is the total value, because that total value of the sum is the thing on which further statements in the word problem will play. Weighted average would be a special case of making standard equations. If they say average of three numbers is, let's say, 30, then you should write a1 plus a2 plus a3 is equal to 3 into 30. This is your total sum. After this you will deal with the upcoming information that they will throw at you, but this would be somewhere your starting point. Similarly, a weighted average would be the same situation with the caveat that a certain weightage is attached to this. So if they say that section A has 30 students and section B has X number of students and their scores are 10 and 12, and then they say something about the average score of all the students, then you will write 30 into 10 plus x into 12 divided by 30 plus x is equal to weighted average on which they would have given the information. So this thing would become the total score in this particular scenario. So weighted average is generally used when there are multiple items which are part of your average set. So instead of saying that, instead of giving you the scores of each of these 30 students, what I did was I gave you the average score of these 30 students, nothing else. Thus, incorporating the weighted average concept. Now, the third type of question would be change in data set. So, what you should focus here is what is the initial average? This initial average will correspond to the as is situation, what is described to you. Then they will say that some changes made to the data set, either some new people have joined or some people have left, and you will get to a final average. This final average will correspond to the new data set. Now, in this particular scenario, when there is a change in the data set, 100% of the time they will be talking about the corresponding change in the averages. So, our focus will be on what is the change in the average, and this can be found by equating the positive and the negative differences of each data point. Again, we will shortly see this. Finally, the last category, this is probably 60 to 70% of averages. Most questions are generally asked from this particular topic area, which makes it a bit of a situation for us, because minimum maximum by design are generally things which we are very wary about, because there are chances of making mistakes. So, a general statement, if I make, if a plus b is constant, regardless of what a and b is, then if I say that you should maximize a, would that also mean you should minimize b? Because the sum is constant. So, if a has to go up, b will have to go down so that the sum remains the same. This constant part in this argument would usually be the total sum, hence, the special focus on finding the total. After you write this, after you understand this, that boss, they are asking me to maximize a, but what they are really asking me to do is minimize b. And once you make that understanding, you should then bring in the certain constraints that they would have additionally given to you. One of which is very common, is that all the values are integers, which makes it very easy for you to take the values for b. Again, an example to shortly come up. So first, let's get standard equations and weighted averages out of our way. So this is your last year's question. There are four numbers. Average of first two numbers is one more than the first number, which means if I take the numbers as a, b, c, and d, what they are saying is a plus b by 2 is equal to a plus 1, because first two numbers average is one more than the first number, so it is a plus 1, which will give me or rather, because they have also given me more equations, let me write those and then decide what I should do. Average of first three numbers is 2 more than the average of first two numbers, which means a plus b plus c divided by 3 is actually is equal to 2 more than the average of the first two numbers. And what was the average of the first two numbers? A plus 1 here. Now let's write the next equation. Average of first four numbers is 3 more than the average of the first three numbers, which means a plus b plus c plus d divided by 4 is equal to 3 more than the average of the first three numbers. So 3 plus this number, which is going to be what? 5 plus a plus 1. Now, what they are asking me is the difference between the largest and the smallest number, which means they want me to find d minus a, which also mean that I don't really want to deal with b and c. I only want to deal with d and a. Now, the best way to do that is if I put a plus b plus c from this equation into this equation, I will have d remaining on left side and a remaining on the right side, and hopefully they will align in such a way that d minus a directly comes out. So a plus b plus c will become 3 into 2 plus a plus 1 plus d is equal to 4 into 5 20, plus 4 times a plus 1, which will give me 6 plus 3 times a plus 1 plus d is equal to 20 plus 4 times a plus 1. Now this 3 times a plus 1 will cancel out this 4, and this a I can bring here, which will give me d minus a is equal to 20 plus 1, 21 minus 6, which is 15. So this is a standard average question. There is nothing, there is no addition of new data set, there is no maximum or minimum they are asking us. There are no repetition of items. A is a single item, B, C, D are single items, so though weighted average used, it's a standard average question. However, even then the possibilities of making certain calculation mistakes. For example, if you had thought ki I'll find B in terms of A, then I'll put that here, then you will find C in terms of A, then you will put that here and B here, then it would have been unnecessarily complicated. So this goes back to one of the things that I have told you multiple times: make the adjustments once you have the entire picture ready, because you might figure out a faster way to do the calculations. So if I move ahead to the next question, average of three distinct real numbers is 28. So let me say a plus b plus c is equal to 28 into 3, which is going to be 84. I didn't even read the question afterwards. I just read this line and I am like, I'll write the total first. It is that important. Now the smallest number is increased by 7. So a becomes a plus 7, and the largest number is reduced by 10. So c becomes c minus 10. The order of the number remains unchanged, which means a plus 7 is less than b is less than c minus 10. And the new arithmetic mean becomes 2 more than the middle number. Okay, so what is the new arithmetic mean? A plus b plus c plus 7 minus 10 divided by 3. And this is given to us as what? B plus 2. Now a plus b plus c I already know as 84. I will just directly substitute it. Hence the value of doing this. So 84 minus 3, which is 81, and 81 by 3 is going to be 27. So you will get b is equal to 25. Okay, I already have one of the variables. Let's use the second equation that they have given us. The difference between the largest and smallest number becomes 64, which means c minus 10 minus a plus 7. So c minus a minus 17 is equal to 64, which means c minus a is equal to 81. Now they are asking us for the largest number in the original set. So basically they are asking us for the value of c. You have a plus b plus c here. So you can directly write c plus a is equal to 84 minus b. 84 minus b is going to be what? 84 minus 25, which is 59. So you will directly, if you add these two equations, you will get 2c is equal to 81 plus 59, which is 140, or c is equal to 70 will be your answer for this question. So again, standard equations. There is no minimum maximum asked. There is no addition of a new data point. This is simple equation solving. Correct? All right. So we are slowly making our way towards the harder parts. Uh, Now let's talk about weighted average. A company has 40 employees whose names are listed in a certain order, not interested. Year 2022, average bonus of the first 30 employees was 40,000. Last 30 was 60,000. And of the first 10 and last 10 together was 50,000. Which means that this 40 employees, I should break into certain groups, of which I will deal with the averages. So what I am thinking is I will break it into first 10, then the middle 20, and then the last 10. And let me say that their averages are A, B, and C. So what are the data points that they have given me? Average bonus of first 30 employees was 40,000, which means 10 into A plus 20 into B is going to be equal to what? 30 into 40,000. Correct? So I basically just calculated the weighted average. Secondly, uh, of the last 30 employees was 60,000. Correct? Which means uh, 10 into C plus 20 into B is equal to 30 into 60,000. Correct? Now, first 10 and last 10 together was 50,000, which means 10A plus 10C is equal to 20 into 50,000. Now, three equations, three variables. Can you find A, B, and C? Yes, we can. And there is a very easy way to do this. You can subtract the first two equations and then you can add it to the third equation and you will directly get A or C. So if you subtract the first two equations, you will get 10C minus 10A is equal to 30 into 60,000 minus 40,000, that is 20,000. Correct. Now, if you add these two equations, you will get 20C is equal to this is 10 lakh plus 6 lakh, 16 lakhs, or C is equal to 16 lakhs by 20, which is what? 80,000. So you have C as 80,000, which you can now put back. If you cancel this out, you will get A plus C is equal to 1 lakh. So A is equal to 20,000. And if you cancel this, you will get C plus 2B is equal to 1.8, which means B is equal to 1 lakh or B is equal to 50,000. After this, what are they saying? Bonus of first 10 employees increased by 100% and last 10 employees increased by 200%. And for the remaining, it was unchanged. So now this is given to you as 20K, this is 50K, this is 80K, this increased by 100%. So this became 40K. This increased by 200%. So this becomes what? 240K, and this remains as 50K. So now again you will have to calculate the weighted average. So 40 into 10, or actually you can just do 40 plus 50 into 2, that is 100, plus 240 divided by 4. Divided by 4. Correct? Because you are taking weighted average. So 1 plus 2 plus 1. I have cancelled out 1 0 everywhere. These many thousands will be your answer. So what method one is, the average given to you is A. So I will assume, that all the ABCs had A amount already. Now for the average to remain as A, D should have had a weight of A only. Correct? In that situation, your average would have remained at this value A only. Now, what they're saying is, however, when you added this person D, your average dropped by X. So, your average dropped by X. This drop from this height will be created by what? The lack of weight of D. Basically, this extra contributions above this new average line of A, B, and C, D was able to eat all of that up along with his own supposed contribution that should have been there. So his own weight, so you go down by x, then you will have to go down by 3x more, because these extra contributions of the first three quantities, d's weight was so less that he had to borrow this much amount x, x, and x from the first three people to even reach this new average line. So from original, you are going to be 4x downwards. I hope this is more clear. The concept of eating up the contribution. Uh, the other person will take up what? He's adding 2x to everyone else and to himself as well. So 2x added to himself and 2x, 2x, 2x added to everyone else. So which makes your average 2 a plus 2x. So he overall added how much weight? 8x weight over this average line. So the total gap between E and D is 12x, which is equal to 12, or x is equal to 1. The normal approach would have been A plus B plus C is equal to 3 times an average, and A plus B plus C plus D is equal to 4 times your average minus X. Okay. Secondly, the new equation for the additional part would be A plus B plus C plus E is going to be 4 times A plus 2x. Now, if you subtract these two equations, you will arrive at d minus e is equal to 12 x directly, and which will turn out to be equal to 12. So you will get x is equal to 1. So you can use your standard equations. It is not going to be, a problem. And, in general, if you are going to be solving averages question, maybe sticking to one method is advisable. The problem is that you might, feel the need to apply allegations later on when we discuss mixtures, which is going to be the same thing. Mixtures is again, you know uh, averages only. That's why we are discussing these two things together. However, when using allegations, this concept of adding and removing becomes more important, because if you don't have that clarity, you can very easily apply allegations in a wrong manner. So I will show you that also. This is your method 1, this is your method 2. In this particular content, context, method 2 seems to be faster, method 1 seems to be more, you know uh, prone to errors. I would accept that. However, I will also show you both the methods for for mixtures as well. It is going to be your call. So if you want to stick to this method too, you can do that. And I mean, for most people, I think writing the equations would be the first step anyways. All right, can we move ahead? Okay, next question. Average weight of students in a class increased by 600 grams when some new students join the class. If the average weight of the new students is 3 kg more than the average weight of the original students, then the ratio of number of original students to number of new students is, the original average is A, the new average becomes uh, A plus zero point 0.6, and the new people who were added, their weight was on an average A plus 3, which would mean what? The extra gaps that each of these people, let's say they are N2, and let's say originally there were N1 people, the extra weights that these N2 people are carrying, which is going to be what? A plus 3 minus A plus zero point 0.6 or 2.4, 2.4 kg into N2. So all this extra weight will go into bringing the average of these A N1 people at an initial average of A upwards to A plus zero point 0.6. So this will become N1 into zero point 0.6. Now you might be able to identify this as allegation, because what do you do in allegation? You write the initial, it is A, the final is what? A plus zero point 0.6, and the uh, additional data point was what? A plus 3. You wrote this as N1, you wrote this as N2, and then what do? You find the gap here. This gap is zero point 0.6. What is this gap? This gap is 2.4. So now for average to be stabilized here, the negative differences have to be equal to positive differences. The negative differences is going to be what? N1 into zero point 0.6, and the positive difference is going to be 2.4 into N2. So you will get N1 by N2 is equal to 4 is to 1 from here also. I think me explaining it to you in a bar chart format uh, is making you a bit wary of this approach, right? Because you are thinking that you will be making these bar charts in the exam. No, you will be doing it like this in a proper allegations format. This is nothing but allegations, this entire bar graph thing that I showed. So this is a very allegation based scenario. If you were to do this in your original manner, you could have assumed N1 into A to be your weight of the first N1 people, then N2 into A plus 3 would be the total weight of the new people. This would get divided by N1 plus N2, the total number of people now. This would be the new average, which is given to you as A plus zero point 0.6. So if you cross multiply and readjust, you will arrive back at this particular result only. Clear so far? Okay, so it's up to you how you want to do these questions. You can very well go with these, but then this is sort of you all uh, turning back at certain situations, because if you remember, I used to be a bit skeptical about this allegations approach, and I have personally done every question in my own CAT exams, both of them, by writing the equations, because in the flow it's very easy to just continue doing that. So it's up to you. Moving on. if you have to maximize, minimizing, maximizing, I think we have already discussed. Find what is constant, then figure out what will you minimize or maximize to arrive at your answer, and then factor in any constraints that are there in this method that you have developed in the step 2. All right, so if we look at an example, average marks of 4 girls and 6 boys is 24, which means 4G plus 6B is equal to 24 into 10 or 240. Each of the girls have the same marks and each of the boys have the same marks. That's fine. Marks of any girls is at most, any girl is at most double the marks of any boy. So girl is less than equal to 2 boy, but greater than equal to B. The number of possible distinct integer values of the total marks of 2 girls and 6 boys. So what we really need here is 2 girl plus 6 boy. I am already given 4 girl plus 6 boy. So because they're asking us for number of possible distinct integers, I have to find the maximum or minimum value of this. Can I say 2G plus whatever my answer is, it is fixed to be 240? 2G plus 2G plus 6B is going to be fixed, which means if I want to maximize my answer, I have to minimize 2G. If I want to minimize my answer, I have to maximize 2G. So I have to technically find the range of 2G, right? And how do I find that? Let me multiply this with 3. I'll get 3G is less than equal to 6B. Now, if I replace 6B here with 3G and get 7G, would I have to say that 7G is less than equal to 240? I will have to say that, right? Because I am replacing 2G plus 6B is not fixed, Adya. 4G plus 6B is fixed. 2G plus 6B is, let's say, X, which I have to find. So I am saying that 2G plus X is fixed. Because X is what? 2G plus 6B. All right, coming back. So if you are replacing 6B with 3G, and 3G is something which is smaller than 6B, which means that this addition will become less than what it should have been. So 7G will be less than equal to 240, or 2G will be less than equal to 480 by 7. This is your maximum value of 2G. Similarly, you can find the minimum value of G as well. If you replace this as 6B is less than equal to 6G, multiplying this with 6, and you replace 6b with 6g, then the sum 4g plus 6b, that is 4g plus 6g, that is 10g, is going to be greater than equal to 240, or g is going to be greater than equal to 24, or 2g is going to be greater than equal to 48. So 2g lies between this 48 to 480 by 7. Now, the maximum value of 2G here will give you the minimum value of the answer, and the minimum value of 2G here will give you the maximum value of the answer. So, because they are not asking us for the exact integer solutions of the answer, can you say that the number of possible values of integers that 2G can take would also be the number of integral values the answer can take, because answer is going to be what? 240 minus 2G. Correct. So you don't have to substitute that and find the expression for 2G plus 6B and then do this. You can immediately find the number of integral values 2G can take. So what is 480 by 7? This is going to be 6. Then it's going to be 60. So 68 point. Uh, Next is going to be what? I think 68.5. Okay, 68.14. All right. Which means 2G can take integral values from 48 to 68, which are going to be how many? 21. So, your answer is going to be 21 for this question. So again, we figured out that to, find the maximum and minimum value of our answer, we have to minimize or maximize 2G. Again, this is a much more complicated version of this argument. We will see easier versions also, but because this is CAT 2023, right? Six distinct natural numbers, average of two smallest is 14. So A, B, C, D, E, F. This is your typical average max minimum question. So not your 2023, not this very conceptual 2022 question. So A plus B is given to you as 28. Average of two largest number is 28. So this plus this is given to you as 56. The maximum possible value of the average of these six numbers. Now a plus b is fixed, e plus f is fixed, which means you want to maximize c plus d, which means you want to maximize c and d. Now what is the constraint that you have to work upon? That the six distinct, they are all distinct natural numbers, which means what? You want to maximize d. D can at max be 1 less than E. Correct. So what is the value that E can take which will maximize D? So E will have to take 27 and F will correspondingly take 29, because F is also greater than E. So if you increase F to 32, E will have to move further away to maintain this 28 average that they have. So to get the maximum value of E, you will have to be as close to F. So the maximum value of E is 27, which means the maximum value of D is 26, which means the maximum value of C is 25. So 28 plus 25 plus 26 plus 56 divided by 6 will be your answer, which turns out to be 22.5. Yes. Same thing happens in this particular question as well. 25 students in an examination is 50 arithmetic mean. Now, so total is fixed at 25 into 50. Five of these students top the examination with the same score. So let's say the total, their average score is A into 5. They will score 5 into A. Score of other students are distinct integers with the lowest being 30. Then the maximum possible score of the toppers is what? So 5A plus sum of these 20 students is going to be a fixed quantity 1250. You want to maximize this, which means you want to minimize this. As 20 can start from 30, and then the lowest values you will take is 31, 32, because they are distinct integers. So the lowest that you can take is from 30 to 49. So you will find this term sum of 30 to 49 and you will get your 5A. So 30 to 49 is going to be an AP, so you can use the AP formula. 20 by 2 into 49 plus 30, that is 79, which will give you the value of A as 92. This is again a typical max min question for average.